Hello guys, welcome to this new video about mesh analysis method. Solved problem number 4. Given the electric circuit with R1 100 ohms, R2 50 ohms, R3 50 ohms, R4 100 ohms, and we have three voltage sources, V1 400 volt, V2 50 volt, and V3 200 volt. The question is using mesh analysis method to calculate the current I. The current I is the current through the resistor R2. Let's go to the solution. Let's start first with mesh 1. By applying Kirchhoff's voltage law in mesh 1, we can write negative V1 plus V2 plus R1 IA minus IB is equal to 0 by replacing the resistors and voltage with their numerical values. We obtain negative 400 plus 200 plus 100 IA minus IB. If we continue simplifying this equation, we obtain negative 200 plus 100 IA minus 100 IB. And if we divide the whole equation by 100, we obtain finally negative 2 plus IA minus IB is equal to 0. After we finish from mesh 1, we go now to mesh 2. By applying KVL in mesh 2, we can write R1 IB minus IA, R2 IB minus IC, plus R3 IB minus V2 is equal to 0. By replacing the resistors and voltages with their numerical values, we obtain 100 IB minus IA plus 50 IB minus IC plus 50 IB minus 50 is equal to 0. If we continue simplifying this equation, we obtain negative 100 IA plus 200 IB minus 50 IC minus 50 is equal to 0. And if we divide the whole equation by 50, we obtain negative 2 IA plus 4 IB minus IC minus 1 is equal to 0. Now we go to the last mesh, is mesh 3. By applying KVL in mesh 3, we can write negative V3 plus R4 IC plus R2 IC minus IB. By replacing the resistors and voltages with their numerical values, we obtain negative 200 plus 100 IC plus 50 IC minus IB is equal to 0. If we continue simplifying this equation, we obtain finally negative 50 IB plus 150 IC minus 200 is equal to 0. Now, if we divide this equation by 50, we obtain finally negative IB plus 3 IC minus 4 is equal to 0. Finally, we obtain three equations which are necessary to find IA, IB, and IC. Let's start now with equation number 1. We have negative 2 plus IA minus IB. Then we can write IA in terms of IB. IA is equal to IB plus 2. Now you would call this equation A. I go now to equation number 3. We have negative IB plus 3 IC minus 4 is equal to 0. Then I can write IC in terms of IB also. IC is equal to IB plus 4 over 3. And I will call this equation B. Now by substituting A and B in 2, we obtain or we derive an equation that exclusively relates to IA. We need to put this equation in common denominators. We obtain negative 6 IB plus 2 plus 12 IB minus IB plus 3 minus 3 is equal to 0. So we obtain, if we continue simplifying this equation, we obtain negative 6 IB minus 12 plus 12 IB minus IB minus 4 minus 3. We have here negative 6 IB plus 12 IB minus IB, we obtain 5 IB, and we have here negative 12 minus 4 minus 3 is minus 19. Finally, we obtain 5 IB minus 19 is equal to 0. That means IB is equal to 19 over 5 is equal to 3.8 amps. We go back now to equation A. We have IA is equal to IB plus 2. That means IA is 5.8 amps. And we go to equation B. We have IC is equal to IB plus 4 over 3. We have IB is 3.8. That means 7.8 over 3 is equal to 2.6 amps. Now we know that I is equal to IC minus IB. We already found IC, that's 2.6, and IB is 3.8. We obtain I is negative 1.2 amps. After we finish calculation, we have done simulation using SPICE simulator in order to verify our results. Let's go now together to SPICE simulator environment. Here is the circuit made by SPICE simulator. We can see here V1 400 volt, R1 100 ohms, V2 is 200 volt, R3 50 ohms, V3 is 50 ohms of 50 volt, R2 is 50 ohms, and R4 100 ohms. If we go to analysis, this analyzes calculate nodal voltages. We can see here IA is 5.8 amps, IC is 2.6 amps, and IB is 3.8 amps, and I is negative 1.2 amps. We see that those values are exactly the same value we have done by calculation. Thank you for watching this video, and if you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share this video, and I see you next time in another example about mesh current method. Have a nice day. Bye bye.